Right, now we're just going to go over a few, well, many actually, mathematical operations in Scheme. Alright, so there's the equal sign, which is, tells you if numbers are equal. What's this? Alright, then there's greater than and less than. It's like less than 3, 6, that's fine. Less than equal to 3, 3. And then greater than, it's like that. Greater than 3, 2. Yes, greater than equal to 3, 3. 3, 2, even, yes, 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 alright. Then there's ABS, which is absolute value. That's like that. Ceiling, which is one you might not have heard of before. That's if you give it like a decimal point number, it will round up. So 3.4 will round up to 4.0. Now how do you round down? What's the floor? 3.4. And then how do you just round? Round 3.4. There you go. Of course, round 3.5 should go up. Righto. Alright. There's truncate, which will just get rid of the decimal points. Truncate 3.2. And that how's that different than round or floor or ceiling or something like that? Well, this is because it'll just get rid of the decimal points even for negative numbers, and it doesn't matter which way it goes. So like negative 3.2 will just be negative 3.0, whereas if you did like what you normally do, floor of 3.2 would be 3.0, but then if you did floor of negative 3.2 you get negative 4.0 because negative is reversed. Alright, so truncate just gets rid of the decimal points. Exponent, I've already showed you that one. It's just like raising something to a certain power, so let's do like 6 squared, which is 36. Alright, now if you want to take square roots, you can do like exponent 9 to the 0.5. Because I don't know if you've learned that in math yet, you probably have. See, then you get 3.0. Okay, that's good. Now let's see here. Oh, square root, actually, there's a square root function. Square root 25. That's nice because it puts it in a integer for you, unless of course you're doing square root like 26, which isn't exact anyways. Alright, then there's max and min, which is very handy sometimes. Max, it will just return the maximum of all the numbers you give it, so you can give it like all sorts of numbers and it'll return the maximum. And min will return the the minimum, so like that. Okay, now let's see, then there's logarithm, just like that. There's sine and cosine, and I do believe these are using radians. Oh, excuse me. Alright, sine, well, alright, then there's quotient 9, 4. That's like a divide minus the remainder, and then you get the remainder like this, 9 and 4. And then modulo 9 and 4 also does that, but let's see with negatives, modulo -2 and 12. Right, so modulo's a lot better for negatives. Okay, now you can try and figure out what's the difference between modulo and remainder. I'm not going to tell you here, but look, there's a hint. Use the negative thing. Now, but if you do remainder -2, 12, there. So think about that for a second. Okay, now we're going to do a simple recursive math problem. Let's define harmonic sum. Now, what's a harmonic sum? The harmonic sum of n equals 1 plus 1 divided by 2 plus 1 divided by 3 plus ... until you get to 1 divided by n. Okay, so this is actually fairly simple. It's sort of just like the factorial function. The base case is what, when n gets I think we'll do this in reverse though. We'll do because this actually equals 1 divided by n plus 1 divided by n minus 1 plus ... until you get to n minus whatever, where n minus whatever equals 0. So we're just going to keep subtracting down on n until it gets to 0. Alright, so we'll define harmonic sum lambda n. Okay, so the base case is if n equals 0, and at that point, oh no, the base case should be if I guess if n equals 1. No, okay, so yeah, we'll just make that 0 because we want to be able to handle if somebody does type in harmonic sum of 0, we want it to say 0. Okay, so if 0 n, then we'll just return 0, and otherwise, well, let's look at this. This is like 1 divided by 1. That's a little more clear. Alright, so otherwise we'll do let's see, we'll do plus of 1 divided by n. That'll give us this, and we have to plus down on 1 n minus 1. Harmonic sum of n minus 1, and that'll just keep subtracting 1 from n, doing this 1 over n, 1 over n minus 1, 1 over n minus 2, ... until n is 0, and then we'll have our harmonic sum. So let's run this. What? Oh right, we've got to delete that. Alright, so let's do this. Harmonic sum of 3. Well, that doesn't mean much. Let's try this. Harmonic sum of 500. Oh, look at that fraction. Look, it's quite sloppy. Now, does that mean anything to anybody? It just means 6 and something. 6 and like something close to 7/9. But so what we can do to make this actually turn into a decimal point, which is a little bit more human readable, we can change this 1 into a 1.0, and that just sort of throws a decimal point into the math equation, which will turn everything else sort of into decimal points. So let's try that again. Harmonic sum of what do we say, 500. There we go, 6.79. Well, that worked out pretty well. Alright, well that's it. In the next video we'll do a we'll try doing list drift.